Good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. We're going to try to actually start this worksheet in Electrons in Atoms worksheet. And I tried to start that last time, but I got carried away and using the periodic table and writing out the quantum numbers. So in order to do this problem here, so let's see here. We got Electrons in Atoms worksheet. This is number one worksheet of one. And it says the first problem is what element has the following set of four quantum numbers for its last electron? And I got carried away last time in drawing out the periodic table. So before you start watching this video, you really need to watch the previous video. And that previous video is quantum numbers on the periodic table. That is essential that you watch that one first. All right, so let's see if we can get moving on these problems here. So I'm going to zoom on in here a little bit. And then we can really get to know these answers for these problems and how to do them. So again, this is Electrons and Atoms worksheet number one. I got 10 problems of similar type. So the first problem, I have n equals 3. So what does that mean? That means I have a 3. So I'm going to put a 3 right down there. Then it says L of 2. Well, what does that mean exactly? So one of the things that you can do, of which I did draw out here on this periodic table, is draw this little table here. So I'm going to draw this table again, even though it's on my periodic table and I can reference it immediately. I'm going to draw that out again, so I think it would be helpful for you. So we have L values and we have orbital types. So atomic orbitals and L values. The L values start with 0, and that is an S-type orbital. And then we have an L of 1, and that's a P-type orbital. And then we have an L of 2, and that's a D-type orbital. And then we have an L of 3, and that is an F-type orbital. Okay. Now there are more L values and there are more different types of orbitals, but that's all what is included on our current periodic table at this moment in time up to element 118. All right. So what we're going to do is look at, we have our n equals 3, wrote that down. L of 2, what type of orbital is that? So L of 2 is a D-type orbital. So now we know that we have a 3D type of orbital. Now, one of the things that we need to do is we're going to draw another column here, another row, and that is the number of boxes or orbitals. So boxes in an orbital box diagram. So you're going to have to continue to watch this video or the next one to figure out what that means. So number of boxes, 1, 3, 5, 7. The next number would be, of course, 9. All right, so since this is a D-type orbital, it's a D-type orbital. How many boxes am I going to draw? 5 of them. So I'm going to draw out 5 boxes here. Okay, and those boxes do need to be attached. That's 1, that's 2, that's 3, and that's 4 and 5. There we go. Now what we're going to do, so we're going to label these boxes. It's always an odd number of boxes. We're going to label the boxes. That's 0, that's 1, that's 2, that's -1, that's -2. These numbers are the 3D orientation of the orbital along its XYZ axis. Although you can imagine that this is a number line. It is not, but you can just pretend. All right. So this m sub L value of -1 lets us know which box we're in. So now we know we are in this box right here. Furthermore, the electrons are placed in these boxes in a certain order. That order is first principally on the left-hand side, you have an up arrow, and then you go into the next box and the next box and the next box and the next box, all with up arrows. And then you start backfilling them with down arrows. You need to know that the m sub s value is the spin of the electron. And when it is up, it's positive. When it's negative, it's down. So this one right here is a downward facing arrow. That is a counterclockwise spin. So you do need to understand that component to this. Okay, so now what we're going to do is we're going to place these electrons in these boxes, in these orbitals, according to Hund's rule, Pauli exclusion principle, and the off-bow principle. So you do need to know those rules, look those rules up, and make sure that you know what they mean. Okay, so those rules mean the following: that no set of 4 quantum numbers can have this. No electron can have the same set of 4 quantum numbers in an atom. That's one of the rules. Another rule is the maximum multiplicity. That is the maximum number of paired spins. And another one is that the electrons are placed in the atom in terms of lowest energy first. So here we go. Up arrow, first box. Up arrow, second box. Now, this is the correct box, but it's the incorrect spin of that electron. Then the next box is up, the next arrow is up, and the next arrow is up. This is actually the maximum multiplicity, maximum number of parallel spins. That's one of those rules. I want to make sure that you look that rule up. It's the Hund's rule, off-bow principle. Or the Pauli exclusion principle. So make sure you know which one that is when you have the maximum number of parallel spins. Look that up so that you understand which one that is. It's very critical. So these are 5 electrons. The 6th electron is right here down in that box. And then the final electron is going to be this one right here. So why am I stopping right here of this green arrow? I'm stopping right here because I am in this m sub L of -1, that orbital, that box, and I have a -1/2 spin. That's why I'm going to stop there. So what I'm going to do is count the number of electrons in which I have. A total number is 1, 2, 3, 4, 5, 6, and 7. So this is 3D7. So I'm going to look on my periodic table, and I'm going to find an element that ends in a 3D7. Right? So here's my periodic table, and this is the 3D, and then it's 3D 1, 2, 3, 4, 5, 6, and 7. So it's actually going to be cobalt. Right, so this element right here, for this one, let's see here, we'll draw this right here. This will be cobalt. Here we go, cobalt, and that is element number 27. Okay, there we go, perfect. So, to me, that is kind of the lengthy, long way of looking at this. So what I'm going to do is show you how to do this an alternate way. So what we have is n of 3. When it is an n of 3, so I'm going to zoom on out here a little bit. Okay, when it is an n of 3, what do I know? What information I know is that I know it's either one of these 2, it's one of these 6, or it's one of these 10 atoms. Why? Because those are all n of 3. When it says L of 2, it's a D subtype of orbital. So that means it is not these 2. It is not one of these 6. It must be one of these 10. Okay, perfect. Then when it says M sub L of -1. So if you follow my previous video, then the M sub L of -1 is right there. So it's either titanium or M sub L of -1, or it's cobalt. One of these 2. Now my last quantum number, m sub s of -1/2, that lets me know it's, so the first half of the Ds and the second half of the Ds have 2 different spins. The first half is +1/2. The second half is -1/2. So that means I'm in the box -1 and I am in a -1/2 spin. So it's cobalt. I find that this is probably the easiest way to obtain that information right there. But I've given you 2 different methods of attempting to get that. So give it a try with both of them. Give it a try with both of them. And then with both of them, you should be able to ascertain your answer. All right. So let's give the next one a try and we can go from there. All right. So it says n equals 5. Okay. So that means it's 5. L equals 1, I'm going to go over to this table here. L equals 1, that's a p-type orbital, so it's a 5p. All right, and then from here, then it's m sub L of +1. So that just needs to have a 1 there. Doesn't need to have the plus, just FYI. All right, so m sub L of plus 1. Now, we're going to go back to the P's. It's an L of 1, and how many boxes do I draw? 3. So I'm going to draw 3 boxes right here. 1, 2, 3. They are all attached. I'm going to label the M sub L values. That's 0 for the middle box, 1 for the right-hand box, and -1 for the left-hand box. Which box am I in? I'm in the plus 1 box, which is this box right here. It's a plus 1/2 M sub S. And so I'm going to have the following arrows. That's 1, that's 2, and that's 3. So I'm going to have 5p3 as my ending electron. So I'm going to go over to my periodic table and find out where 5p3 is on my periodic table. And so these are the p's right here. This is p2, 3, 4, and 5. So 5p3, 5p1, 2, and 3. So it should be SB, and that's element 51. So it's SB, element 51. That's antimony. So that's how I'm going to get that. I'm going to give this a try by looking at my periodic table. I do find it a little bit easier and faster if I look at my periodic table. So I have an N of 5. So what does that mean here for my periodic table? It could be one of these 2. It could be one of these 10. It could be one of these 6. It could be one of these 14. All right. But when it says L of 1, that tells me it's a p-type. So L of 1, when it's a 5, so it's a 5 and a p, and it's one of these 6. So now I'm going to fold my periodic table here, and I'm folding out the F's, I'm folding out the D's, and you should see that the S's and the P's are cohesive in their principal quantum number. That's N value. So the 5s of the S's and the 5s of the P's are in the same horizontal section. All right, so we've figured out that it's a 5p, and then it's a plus 1. It's a positive 1 in the box. So these are the p's. So it's one of these 5 right here. These are the p's, this whole block right here. So it's one of these 6, excuse me. And so it's a plus 1. So it's either antimony or it's xenon. And that last quantum number of being plus 1/2 tells me it's in the first half. So that would be antimony. That's element 51. Boom. That's exactly what we got right here. All right. So let's see if we can keep on moving to this next one. It says N of 3. So that is a 3. I'll write that down. L of 1. L of 1 is a p-type orbital. I'll write that down. How many boxes do I draw? 3. So I'm going to draw these boxes here of 3 boxes. 1, 2, 3. I'm going to label them just like as such, like a number line. It's in M sub L of -1. So it's in this box right here. And it's a plus 1/2. So I'm going to stop when I hit a plus 1/2, which is an up arrow. So that it is right there. It's a 3p1. That's the last electron. So let's see if we can come up with that one. So again, if it's a 3p1, that is a 3. These are the p's, and it's 3p1. There we go. Aluminum, and that's element number 13. Aluminum, and it's element number 13, just like that. So if we just look at our periodic table, then we can actually answer this too. It's an N of 3. So when it's an N of 3, it's either these 2, it's one of these 6, or it's one of these 10. Okay, the F's are 4s and 5s, so we can actually get rid of that block. Then it says it's an L of 1. So knowing that it's an L of 1, it's not these L of 2, it's not a D, it's not an L of 0, it's not an S. So we're going to get rid of all of that. So we're left with just this right here. Okay, just these 6. And then it says M sub L of -1, M sub L of -1. So M sub L of -1. So it's either going to be M sub L of -1. That's either aluminum or it's going to be sulfur. Since it's a plus 1/2 for the spin, it's in the first half, and that would be aluminum. Bingo, aluminum. I find that that's very much easier than doing it the other way here that we have been doing, but it's up to you entirely. So let's try another one. N of 3, so that's a 3, and L of 2, L of L of 2, that's a D, so I know it's a D. How many boxes do I draw? 5. So I'm going to draw 5 boxes right here. 1, 2, 3, 4. I'm going to label those boxes with the M sub L values. And that's what I have here. It looks like a number line. It is not. It's in box M sub L of 0. So I am going to stop once I hit an electron in that box of the -1/2 spin. So remember, the electrons go in the following order. It's up, 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 down, down, and then finally down just like that with my last green electron. How many electrons do I have? 1, 2, 3, 4, 5, 6, 7, 8. So this is 3D8 is what I should be having here. So let's see if we can find 3D8 on our periodic table. Okay, this is the 3 and D's, and it's 1, 2, 3, 4, 5, 6, 7, 8. It should be nickel, and that would be Ni, and that is element number 28, atomic number 28. Perfect. So let's see if we can use our periodic table to answer this. So it's N of 3. So N of 3 limits it to the following 2, to the following 10, or to the following 6. That's just the N of 3. When it says L of 2, then I have limited it even further, and now I am looking at just these 10 in the N of 3, so it's one of these 10. Okay, then from here, it's M sub L of 0. So M sub L of 0, so it's either going to be vanadium, that's a 0, M sub L, or M sub L of 0 as nickel. And since the M sub S is -1/2, it's in the second half, so it's going to be nickel and not vanadium. So nickel and not vanadium, perfect. All right, so let's keep on going here and see if we can hammer out some more of these. The next one is N of 4, so I'm going to write down a 4. L of 1, that's a P subtype of orbitals. Okay, and it's a P, so I'm going to write down 3 boxes. So I'm going to write down 3 boxes right here. I'm going to label those boxes with my M sub L values. Those are the M sub L values of -1, 0, and 1. I am in which box? I am in box 0. So I'm in this box, M sub L box of 0, and it's a -1/2 electron. So remember, it's the first electron is up, second electron is up, third electron is up, and the next one, fourth, is right there down. And then finally here, I am down in this final box of M sub L of 0. So how many electrons do I have? That would be 5. So it's 4p5 is what I'm going to find on my periodic table. So 4p5. So right here is 4. This is 4s. This is the 4p. 4p 1, 2, 3, 4, and 5. So it should be Br, that's bromine 35. So Br, that's element number 35, should be just like that. Okay, and so let's look on our periodic table and see if we can answer this one here. So it's N of 4. So when it's an N of 4, it can be the following elements or the following sets of elements. And that is, it could be one of these 2. It could be one of these 10. It could be one of these 6. Or it could be one of these 14 right here. But further delineation, further refinement, L of 1, that means it's a P subtype. So I'm going to get rid of the F's, the D's, and the P's. Just get rid of, the S's, the D's, and the P's. Oh my gosh, let's try this again. We are going to get rid of the F's. We are going to get rid of the S's, and we're going to get rid of the D's. And so what we are left with the P's. So it's a N of 4, L of 1, it's a 4p. 4p, 2, 3, and 4. So it's one of the 6 elements now. Now I have more refinement of these numbers, and that's M sub L of 0. So that means it's either M sub L of 0, that's germanium, Ge, or it's M sub L of 0, and that's bromine. And since the M sub S value is -1/2, it's in the second half, it must be bromine. Bromine. Perfect. End of story. Done. We're looking good. All right, so we are done with half of these 10. Let's do the other half. Okay, so we're going to start off with n of 6. So we're going to write down a 6 right there, and then L of 0. So what is the L of 0? That is an S-type orbital, so that's an S. How many boxes do I draw for S's? 1 box. So I'm going to draw a single box. That M sub L value is a 0. So it's an S-type orbital. That's the L. The M sub L has to be 0 when it's an S-type orbital. It's a plus 1/2. So that means I'm going to end with this one single electron, and that is 6s1. So I'm going to look on my periodic table. Okay, here's my periodic table. It's a 6, it's an S, and it's a 1. That's cesium element number 55. So we'll write this right up here, CS, that's 55. Just like that. So if I look at my periodic table, it's n of 6. So n of 6 could be the following. It could be one of these 2. It could be one of these 10. It could be one of these 6. And it could be in the 14 range of the Fs, but we don't actually have those for real, true, actual elements. So we'll skip that one. But then our next is an L of 0. That lets me know it's an S type. So I'm going to get rid of the P's. I'm going to get rid of the D's. I'm going to get rid of the F's. So now I am left with just this block here. I'm left with these 2 elements. That's it. When it says N of 6 and L of 0, I only have cesium or barium. That's it. M sub L of 0, they're both in that. Plus 1/2, plus 1/2. It's the first one of the 2. So it's cesium. Perfect, done. Now we're going to do the next one, which is number 7 here. And number 7 is N of 4. So we'll write that down, 4. L of 2. So I'm going to come over here, L of 2, that's a D subtype. And Ds have how many boxes? 5. So I'm going to draw out 5 boxes here. 1, 2, 3, 4. I'm going to label these boxes with their M sub L values. That's 0, 1, 2, -1, -2. Okay, I'm going to draw the electrons in there after I figure out which box I'm in. I'm in box M sub L of 0. So I'm in this box. I'm going to stop in this box once I hit a -1/2. So it's going to be up, up, up. Oh, wait, that's a positive 1/2. So I got to keep on going. Up, up, down, down, and here we go. We are going to stop right here, down right there. I'm going to count up the electrons, 2, 4, 6, 8. So it's 4d8 is what we're looking for, 4d8. So where is 4d8? Well, here is the D's in this block right here. This is the 4D. So it's 4D, 1, 2, 3, 4, 5, 6, 7, 8. Palladium, number 46. So it's PD, number 46. All right, let's look at our periodic table and let's see if we can answer that same question. So it's N of 4, L of 2. So it's N of 4. What does that mean? When it says N of 4, it could be one of these 2, one of these 10, one of these 6, or one of these 14. But when it says L of 2, that delineates it down to N. L of 2, that's a D type. So it's one of these 10. So I'm going to fold this, get rid of the F's and the P's. It's just a D. It's N of 4. So it's 4. It's one of these 10 right now. Now, when it says M sub L of 0, that means it's either NB or PD. -1/2, it's in the second half. This blue line is the first half on the left, and on the right is the second half of -1/2. So it's element number 46, PD. Perfect. Professional development. Number 8, N of 6. So I'm going to write a 6 down. L of 1. L of 1 is a P. Perfect. For the P's, I write 3 boxes. So I'm going to write my 3 boxes here. I'm going to label my boxes with the M sub L values. That's 0, 1, and -1. Which box am I in? M sub L of 0. So I'm in this box right here yet again. And I'm going to draw arrows until I get a positive 1/2 in that box. So I'm going to have an up and then, oh, wait, an up. And that's 1, 2. So I'm going to be ending with a 6p2, just like that. So I'm going to look on my periodic table and I'm going to find 6p. So right here is my periodic table. There's 6, that's 6s. This is 6p right here. The 6p1, 2. That's pb 82. So it's pb 82. All right, perfect. Let's see if we can do that using our periodic table only. So we have n of 6. So when it's an n of 6, what do I have? It's n of 6. It could be one of these 2, one of these 10, one of these 6. It could be some of the F's, but we don't worry about that because the F's of which we have for real actual elements are only 4s and 5s. So we're going to get rid of the F's, but that is possible. There are the next letter as well, but we won't worry about that. So n of 6, L of 2. When it's an L of 2, it's a D. So now I'm looking at 6D. I've narrowed it down right now to just 10 elements. It's 6D. Wait, sorry. N of 6. I apologize. I was going for the next one. N of 6, L of 1. That's a 6P. So I'm looking at 6p. So here we go. 6. So this is 2, 3, 4, 5, 6p. So it's one of these 6 right here. Then it's an M sub L of 0. M sub L of 0. It's either 82 pb or M sub L of 0 of AT. And so it's a plus 1/2. So it's in the first half. So it's pb 82 right there. 0. M sub L plus 1/2 pb 82. Perfect. All right, let's go for the next one. That is going to be an n of 6. So we're going to write down a 6. L of 2, L of 2, that's a D. So it's going to be a 6D. How many boxes do I draw? 5 boxes. So we're going to draw 5 boxes. A lot of boxes here. 1, 2, 3, 4. We're going to label these boxes with their M sub L values, just like that. Looks like a number line. It's not. I'm going to be in box number +2. So I'm going to be in this box of +2, and I'm going to have a positive spin. So it's going to be up 1, up 2, up 3, up 4, and up 5, just like that. I'm going to end there. I have 1, 2, 3, 4, 5 electrons. So it's 6d5 is what I'm looking at. Okay, let's see if we can find the 6d5. And so we're going to look on our periodic table. And we've got 6d. These are the D's. It's 6, 61, 2, 3, 4, 5. BH 107. So I'm going to write BH 107. Perfect. All right, let's see if we can get that one just using our periodic table instead. So it's an n of 6. So what does that tell us? It's n of 6. It could be one of these 2. It could be one of these 10. Be one of these 6 here. It could be in the F's, but we don't have those for real, really. So we're going to skip that. L of 2. So it's an n of 6, L of 2. So that delineates it down to the D subtype. So now it is one of these 10 elements. When it's a +2, it can either be BH or this 112. So it's either 107 or 112. Since it's a +1/2, it's in the first half, so it's the BH. Perfect. You got that nailed. Let's do the next one, the last one of this subset. So n of 5. So when it's n of 5, we're going to write down a 5. 5. L of 3. L of 3 is an F type. So we write 5F. So how many boxes do I write for F's? 7. So we're going to have 7 boxes here. We got to get ourselves a little bit more space. 1, 2, 3, 4, 5, and 6. That's a 0, a 1, a 2, a 3, a -1, a -2, a -3. Which box am I in? I'm in box number -2. And I'm going to have a -1/2 electron. So I'm going to have up, up. It's the right box, the wrong spin. So I got to keep on going. Up, 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 down, and finally, oh yes, here we are. That's right. This one right here, down. So how many electrons? 2, 4, 5, 6, 7, 8, 9. So it's a 5F9 is what we're looking for, 5F9. So we're going to look at our Fs and the 5Fs specifically. So these are the 5s, these are the Fs, 5F 1, 2, 3, 4, 5, 6, 7, 8, 9. That's CF 98. So it is element CF, that's 98, that's Californium. Okay, so let's see if we can do this using our periodic table. So it's an N of 5. N of 5 means that it could be one of these 2, one of these 10, one of these 6, one of these 14. When it's an L of 3, it's an F type. So that means it's an F type. So I'm going to fold everything else out except for the S. So I have the Fs now here before me, and I have the 5Fs. So it's one of these 14. M sub L of -2. That means it could be either -2 PA or -2 CF. Since it's a -1/2, it's in the second half, so it is CF, element number 98. Bam. Perfect. I think you got that nailed. So I'm going to leave that right there for you here for just a moment. You're going to make sure that you have labeled your periodic table. Have you watched my videos on my lecture? If you haven't, you really need to, because my videos on my lecture really cover all this material in detail with examples, and these worksheets reinforce that. So what I want you to do is watch my video so that you can reinforce what you are learning right here with these. And you also need to pull out some periodic tables and label them just like that with all their quantum numbers. So really work on those quantum numbers for those periodic tables. Remember, you are watching the Crazy Hat Chemist, a little bit of self-advertisement here. I hope you have a fantastic day, and you'll see another video with the next part of this here. All right, we'll talk to you then. Bye for now.